everyone. Today we are going to finish off 8.2. So, to remind you, here are the 4 different situations with the appropriate formula when you are looking at finding the volume of the surface area of revolution. So these 2 are when you rotate it about the x-axis, and these 2 are the formula that you rotate about when it's being rotated about the y-axis. So you probably should have these written down somewhere, so that when it comes to doing your test, you can scan through the right one. So far, so good, right? So jump right in, and well, I guess I can keep one of these here, and we'll look at this fella. X equals, this is like question 6, x equals 1/3 y squared plus 2 to the 3/2. Okay, so I guess the most important thing we need to do right now is to figure out which one of these, oh, there's a piece of information I better tell you. I'm going to rotate this about the x-axis, right? If you don't have that, then you're missing something important. Right, so we got to figure out which one of these is the guy that is the right formula. Now, since it's rotating about the x-axis, it's one of these 2. And it's written in this format. So does that make it situation 1 or situation 2?
2.
Is it pretty easy to tell? Would you agree? Rotate about the x-axis, and then you pick the one with all the y's in it. So now that we have that, I can do the surface area. It's going to be the integral from c to d, 2 pi y, the square root of 1 plus dg dashed of y squared dy. I'll move this, well, put in some details, then I'll move it. It's integral from 4 to 5. I'll stick the 2 pi out there. Keep the y. 1 plus g dashed y squared dy. There's some of the details. Now what we have to do next is essentially focus on making this piece here as nice as it possibly can, right? So we are going to be looking at that fella. So I'll start off with what I'm calling g of y, basically x. It's 1/3 y squared plus 2 to 3/2. So I'm going to differentiate it. So I'm going to multiply by the power, which gives me a half. Going to reduce the power by 1, which gives me a half. And then I'm going to times. And what am I going to times it by? Because this is a chain rule, a differentiation chain rule.
2y.
2. Right? Right, the derivative of y squared plus 2. Now the half and the 2 cancel out, gives me y, and this guy, according to style points, looks like that. So remember the rules of style points. One of them is make it look like the original. Well, in this case, I'm breaking that rule, but that's fine. Sometimes you have to. And the reason I'm doing that, although I could have left it as half power, I guess, is so that I can find 1 plus that fella. And it's going to be 1 plus this guy squared.
Where did the 1/3 go?
Where it get multiplied by the 2/3 and cancelled down to a half.
Okay, thanks.
So what do I get? I get 1 plus y squared plus 2. And that looks like 1 plus y to the 4 plus 2y squared. You all with me? Now, this is going to go inside the square root. Which means I'm going to have to figure out how to make that pretty. Oh, and by the way, did you notice that you write them down in order of power, highest to lowest? That's one of the style point rules. This is a square root with 3 things in it. If you see a square root with 3 things in it, what should you be thinking?
Square.
Okay. And what perfect square is that guy?
Y squared plus 1.
Hope we all can see that. Agreed? Which means that this fella ends up being y squared plus 1. Isn't that quite elegant? I mean, look at where it started life off as. Look all the things that happened to it. But look where it finished. Just as y squared plus 1, which means that we can now do 2 pi, the integral from 4 to 5, y times y squared plus 1 dy. And that needs just one more thing. What do you think I do next to this integral?
Multiply it out.
Yep. And that gets me y cubed plus y dy. And at this point, I'm going to do a dot, dot, dot. Would you agree this is just a power rule with some ugly fractions and some yucky number at the end with a pi? Right? So the vast majority of the work that we did was just to make this thing here nice. And quite a lot of questions, that's really where most of the work's going to be, isn't it? In making this thing nice. A lot of algebra, but it did its job. This is question 8. Y equals I don't know if I done this one. It kind of looks familiar, but I don't know if I have. Does that look familiar to anybody? Maybe it's just me. Maybe I did it with the other class. Doesn't look familiar? Okay. Now, since it's being rotated about the y-axis, it means it's situation 3 or 4, right? These are the two that you use when you rotate about the y-axis. This is the formula or the function with its information that's going to be rotated. So is it situation 3 or is it situation 4?
Three.
Great. So we are looking at a surface area, the integral from a to b, 2 pi x, square root of 1 derivative squared dx. That should be your first decision, which formula to use. And doesn't it depend on the question itself, right? Am I rotating about the x? Am I going to rotate about the y? Is it a y equals x cubed or is it an x equals y squared plus 1, right? That kind of decision eventually allows us to choose the correct one. So in this case, let's find out what the square root looks like. So f of x is 1/3 x to the 3/2. So its derivative, multiply by the power, reduce it by 1. In a lot of ways, this is kind of deja vu. You agree? Now, if you differentiate this fella, and you now square it and add 1, are you okay with that? Are we good? So the square root of all that stuff ends up being that. So I'm going to swap places here. And so I have the integral from 5 to 12, 2 pi. I have an x. I have this 1 plus a quarter x. And I have a dx. Now, I would have loved that to be nicer, but sometimes you don't get what you want. That's as good as that's ever going to be. So now we are left with a puzzle. We need to integrate this. And the candidates for this are quite limited. It's a U sub or it's an integration by parts. Now, the reason why it might be, I'm not saying it is an integration by parts, isn't it 2 things multiplied? Now, superficially, that might look like it's the best candidate, right? You know, make that F, make that G, or make that F, make this G, whatever it is. Can you trust me? It goes south on you a little bit. In other words, it's unless you use tables, it's impossible. So let's not go there. And that will happen sometimes, that you'll choose one strategy and after 2 or 3 lines, you'll look at it and say, God, this is getting even worse. This is probably not the way to do it. In which case you just kind of throw that piece of paper away and you say, okay, if integration by parts doesn't work, because Professor Robertson has told me it doesn't and I'll trust him, then it has to be a U sub. And the U sub is not going to look right for a couple of lines. It will work, but it won't look right. What should you use as a U sub in a question like this? Because it's a little bit weird. The choice of U sub is not a little bit weird. It's the math that comes later that is. So what's the U sub?
It's just going to be 1
plus
plus,
one.
yeah, the whole thing.
Yeah, agreed. When you differentiate with respect to x, you get a quarter. If you do the old crossover, you get that. There's nothing too weird yet, right? So it's going to be 2 pi, the integral of x square root of u times 4 du. And this is where the weird stuff happens. We've got an orphan x. We don't like orphan x's because orphan x's mean that you can't go, right? You got to get rid of the x. So how am I going to figure out how to turn an x into something as using it?
Can you convert the U sub?
Okay, so I'm going to take this U sub and I'm going to solve for x. So I'm going to subtract 1 from both sides. And then I'm going to multiply both sides by 4. And now I have a replacement that can replace the x. So we now have 2 pi 4u take away 4. I'm going to turn the square root into a half power. And I don't know why I've still got that 4, but I guess I have. Du. What do I do next?
Take the 4 out and distribute the U.
Okay, so if I take the 4 out, it goes over there. If I distribute the U, we get to this stage here. Now, would you agree we're now at a point where we can use the power rule? The answer is going to be in terms of U. Won't you replace the U with 1 plus a quarter x? And then you can plug x equals 5 and x equals 12. So ... we're finished. So integrate using the power rule, replace the U with 1 plus a quarter x, then plug in x equals 5 and x equals 12, and you'll have your answer. If I wish I had time, I would try and do that question using integration by parts and just show you why it didn't work. And sometimes you won't know something doesn't work until you've tried it, and that's okay. As long as you know, well, if it's not the first, it has to be the second, right? Okay, let's move on. This is question 12. (9x) equals y squared plus 18. And this is going to be rotated about the x-axis. Any suggestions about what we should do? Now, since we're rotating about the x-axis, right, it has to be one of these two, right? This looks like the information is kind of mixed up. You're rotating about the x-axis, but it looks like it's been written as 9x equals this guy, right? There are 2 roads to go. 2 ways of solving this problem. Situation 1 is, couldn't I just take this, divide everybody by 9, and now I have that. And if you plug x equals 2 in here, you get y equals 0. And if you plug x equals 6 in here, what do you get? 936, 18, you get the square root of 18. And now you can rotate it about the x-axis. Or I could take this guy, subtract 18 from it, and then take the square root. I'm assuming it's a positive 1. And now rotate this fella about the x-axis. So what that is saying is, if I decide to use this version, won't it be situation 1? And if I decide to use this version, won't it be situation 2? You agree? So the question is, which one? Any ideas? A or B, first or second? Which you think is going to be the least amount of work?
A looks easier.
The first one.
Yeah, I would agree. Now, all of us, including me, could be wrong. But I would go for it first. And if it works out nice, I'd be happy and I'd say, hey, I'm good at guessing. And if it goes south on me, I will just stop and I'll say, okay, then if it ain't that one, it's going to have to be this one. Now, if I keep this one, Won't it be situation 2? My gut feeling is that this is going to work out well. But, you know, sometimes my gut feeling is wrong. So I would choose that one. And that's all I'm going to do with that one. You're given this guy. It's going to be rotate about the y-axis. Okay. And we're being asked, oh, and x is going to be from 0 to 5. Now, since I'm rotating about the y-axis, looks like that. Great. And so which one? 3 or 4? 3 or 4?
3.
That's 3. So the surface area is going to be the integral from a to b 2 pi x square root of 1 plus the derivative squared dx. So in this case, it's going to be the integral from 0 to 5. There's going to be an x. I can do this one probably in my head. If you differentiate this, don't you just get negative 2x? And if you square negative 2x, you get that guy. Okay, what method shall I use to solve this puzzle?
U sub
And the u sub will be correct.
1 plus 4x squared.
And can I just say dot, 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 dot? Just want to give you the intro to this question, right? Show you where it leads to. Are we comfortable about the dot, dot, dots I've done today? Because if you're not, you're allowed to say, can we see a little bit more? I'm not really sure where this is going to go. And you're allowed to at any time to say that. Okay, so we're going to rotate an infinite curve, which by the way, it looks like this. And we're going to do it from 0 to infinity. So it's basically this guy. It's going to be rotated about the x-axis. So looks very like a Gabriel's horn question, doesn't it? So we're being asked to calculate what the surface area. Well, since you're rotating about the x-axis, it means it's number 1 or 2. And since everything is in x's, would you agree it's number 1? So what makes this a little bit different? You're going to do the integral from 0 to infinity of 2 pi f of x, the square root of 1 plus the derivative squared dx. Now I'm only going to take this guy a little bit further. Since it's got an infinity in it, we're going to do the limit as t tends to infinity of the integral from 0 to t, and I'll stick the 2 pi outside. F of x is this guy. Okay, do it in my head. If you differentiate e to the negative 5x and then you square it, can you trust me that you get that? Because I don't have a lot of room. So you differentiate that guy and you get negative 5e to the negative 5x. And if you square negative 5e to the negative 5x, you get 25e to the negative 10x. Now this guy is a really cool question, because this guy is a u-sub. And not only is he going to be a u-sub, after the u-sub's finished, you're going to have to look up the tables. So let's start with the first puzzle. What on earth u-sub is going to get me out of this hole? If you're saying something, Ian, I can't hear you.
Is it going to be e to the negative 5x?
I would accept that and that would work, but can you adapt it a little bit more and we're good to go? You're definitely, that is a good choice. What else?
Okay, just add the 25.
Wind back a little, not all 25.
5?
Yes. Now let's see why that is going to work out. Well, e to the negative 5x, we'll worry about him in a minute, right? This thing becomes 1 plus u squared. Do you see how pretty it is? Now, if you differentiate with respect to x, you get that, which is not very nice. And I'm running short of room, so that is the guy. Oh, yeah, I better do that again. I've given myself far too little room. So I'm just rewriting this again with more room. If you differentiate with respect to x, you get this guy. If you do the crossover, you get du is negative 25 e to the negative 5x dx. And if you isolate it, you get your dx. So this fella here gets replaced by all of this. So you get 1 over negative 25 e to the negative, where am I? 5? That's 5. E to the negative 5x du. Those cancel, and you are left with a negative 1/25th square root of 1 plus u squared du. I'm going to suck out that negative 1/25th and get that guy. Do you see that that guy is from the tables? And I have in Canvas a PDF of the values for the table. So if you go and look at Canvas, you'll find that guy. I think it's about 7 pages. So if you've got a printer, you might just print the whole damn thing out and get it over with. At this point, all you're going to do is integrate it. And if that wasn't enough, then you plug in t and then you do brute force. So there's still a fair amount to do in that question. But at least I gave you hopefully a good start. So the last bunch of questions are going to be, excuse me, relatively quick, I hope. So while I'm getting this set up, will you lot say hi? Get attendance. Oops, that's annoying. You've got the answer, but never mind. We'll show you in a minute. Okay, what you're going to do here is, and the key here is set up, but do not evaluate. So you're just going to set up the integral to the best of your ability, and then it's one of these. Now that one unfortunately has a key, so you know it's going to be that one. And so this shape is going to be rotated about the x-axis, and this one is going to be rotated about the y-axis. So let me, there should be some more people. 2, 4, 6. There should be 2 people saying hi. So who are you? Type in hi. Jocelyn, can you hear me? Okay, one person. Jocelyn, can you hear me? That might have been you that said hi. Okay, so where was I? This fella here about the x-axis. Well, since it's about the x-axis, you agree it's 1 and 2. Everything is xy, so it's 1. So the answer to A is going to be the integral from 3 to 5, 2 pi f of x square root of 1 plus the derivative of this squared. So what is the only piece that's missing? The derivative of this. So you will have a little bit of work to do. How will I differentiate this? What method?
GF prime time or plus FG prime.
Okay, so the product rule.
That one.
Yeah. What you said is correct. It's just not the way I was taught it. It's the same formula, it's just written down differently. This will be F, this is G. If you differentiate this, you get 1. And if you differentiate this, remember, you get the negative thing. So what do you get? You get a 1 take away x e to the negative x. And that's what you put in here. And then you just search through the choices. And I've just looked at it, and that's not the choice. They did one more thing. Right, they did that to it. So basically, they squared these 2 terms. So you will set up the question to the point where it looks something like this, and then you will go and search through the 5 choices and figure out what it should be. So I'm going to scroll to the next one. In this one, it's going to be y equals the inverse tan of x. And x is going to be from 4 to 8. And we'll do, the first one is going to be about the x-axis. Which means it's situation 1 again. So it's integral from 4 to 8. 2 pi inverse tan of x 1 plus the derivative of inverse tan squared. What is the derivative of inverse tan?
Uh, 1/1 plus x squared.
And you might want it to be written that way, but what they did is really just cosmetic. They changed that into this. And then you go hunting for whichever one looks like that guy. What would be the only difference to this answer if we said change it to be about the y-axis? So
Would
what
tan
would you,
inverse be y?
this guy here, what would he become?
Yeah.
So
Y.
you think it'd be y here? Oh, so yeah, maybe you're thinking that this should be called x equals tan y and then do it that way. Is that what you're thinking? Well, this is a little bit easier. Can I just use formula number 3, which basically says replace that with an x. So it's a little bit quicker. Now, if I wanted to approach that in a totally different way, then I guess I might have to do something like this. If you take the tangent of both sides as an x equal tangent y, and if x goes from 5 to 8, won't y go from inverse tangent of 5 to inverse tangent of 8? And then you could use the formula number 4. I think it'd be quite ugly, but I guess you could have used it. But it wasn't one of the choices, so you wouldn't be able to find the right answer because of that. I mean, if it had been one of the choices, I guess that's the road you should have taken. We have x equals 17. The square root of y, take away y squared. This is going to be my last one for today. Now this shape is going to be rotated. Well, it's going to be rotated amongst a number of things. So let's do the about the y-axis. Now it's x equals this guy, and it's about the y-axis. So since it's about the y-axis, it has to be situation 3 or 4.
Professor,
Yes.
is there a an interval?
There isn't yet, but there has to be one.
Okay.
So we have 3 or 4. Would you agree that the way this is written, that it's a situation 4? Rotating about the y-axis and everything with y's. So what you said is correct. I don't have a C or a D, but I have 2 pi g of y, which is essentially this guy, 1 plus the derivative of this guy squared dy. So there's 2 things that are missing. The first one is I need to differentiate this fella, right? And square it and make it look pretty. And then the other part is I need to know a start and a finish. And I'm going to tell you that the start is 0 and that the finish is 1. And I'm going to ask you, how do I know that? I could have guessed, but I didn't. There's a reason why the y values can only go from 0 to 1.
Is it because other values of y would be you would have taking the square root of negative numbers?
Correct. So doesn't that only exist when y minus y squared is positive? And isn't y minus y squared? I mean, if you turn it on its side, isn't it 0 and 1? So a little bit sneaky, but it was there. The good news is that the 5 choices all told you it was 0 to 1, so you were okay anyway, because it was there. Now, the piece that's missing is kind of messy. I need, we'll call it g of y, because that's what I prefer to call this thing, right? I need to differentiate that guy and square it, right? Would you agree that this is a good old-fashioned chain rule? 1/2, 1 take away y squared to the negative 1/2 power times the derivative of this. Now you try and make this pretty. You got a 1 minus 2y on the top and 2 lots of this guy to the 1/2 on the bottom. Now if you square this guy, you're going to get this fella square 4 y minus y squared. If you do 1 add this guy, you're going to have 1 add that guy. Agreed? Now, I wish I could say that's the thing that you'll find in your choices, but they didn't. They made this a single fraction. So the 1 is going to be called 4 lots of y minus y squared over 4 lots of y minus y squared plus this guy. Then I'm going to multiply all this out and see what we get. On the bottom, I'm going to get that. 4 times y squared. That guy gets you 1 minus a 4y plus a 4y squared. Do you see some really interesting carnage? Kill, 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 kill. So what we are left with is that guy. And so our answer ends up being the integral from 0 to 1, 2 pi, the square root, right, the original function, times 1 over 4 lots of y take away y squared dy. And that's the one that you'll go looking for your answer. So although you were only being asked to set this question up, do you see how much work there was involved in setting it up, right? You didn't even get asked to integrate it. I'm not sure I want to integrate that thing, so I'm glad they didn't ask me to. Pretty ugly. Okay, for the last few minutes, let's do the obvious questions. What's happening on Monday?
Test.
Test. What sections will the test be covering?
Chapter 8.
Chapters 8
Chapters 8. What will we not have in the test?
tables.
The tables. And it will be 8 up to and including this section, right? Okay. Usual time, right? 7 till 9. Get your homework done by Sunday. Do you know, I should just tape myself and run the tape and I could go and have a drink. It's exactly what we did in every other test, right? Would you agree? It's, you know the format, you know the, if this time doesn't suit you, then you contact me, we'll arrange another time. You know that you've got half an hour to upload it into Canvas. You should know by now that if you don't show working, it's going to bite you in the bum. So even in homework, which I totally understand, you may not do working because you know shortcuts and you get answers quickly and whatever. I strongly suggest that you don't try that. Because if the answer is wrong and I have no working, then you've lost all the points because there's nothing I can base it on except what you've told me. So that's probably the only thing I need to emphasize. Any questions? Are we all comfortable? We know what's going to happen Monday? Right.
Does it include 7.8 improper integrals?
Yes. Good question. Yes. 7.8 is part of that. Although it's not chapter 8, it is 7.8. So we're talking 7.8 arc length, right? 7.8 arc length and surface integrals. Okay. Any other questions? That was a good point there, Nicholas. I should have mentioned that.
Do you know how many questions we'll have?
Nope, because I haven't made it and I have to make it tonight because my computer will not be usable all day Saturday for reasons I've already explained. One of the nice things about WebAssign is it tells me how long a typical student took to do a question. So that means that sometimes you get a lot of questions because they all take 5 minutes, and sometimes you don't get a lot of questions because they take 20 minutes. So, you know, somewhere between 6 and 12 would be my guess, right? Depending on the length of the question. I gut feeling is surface area questions can take a lot of time because of all the different, you know, algebra things that you have to do, and maybe a U sub at the end and so on. So they're quite long. Arc length and improper integrals, they're not too long. I think they're okay as far as time goes. So somewhere between 8 and 12 there. Kind of re-estimate of the answer. That would be my best guess right now. Any other questions? We should finish with a joke then. Has anybody got a corny joke?
I was
I'm
gonna tell
sure-
a joke about math, but I was too squared.
Oh, that's very funny. I'm sure I've told you this one, but it's the only one that's came in my head. If at first you don't succeed, don't take up skydiving.
That's
Okay,
pretty good.
bye-bye. Okay, bye-bye, guys. Have a nice weekend. But not too
Thank
nice
you.
weekend because you're studying for your test.
Are you taking questions or no?
No, I'm taking questions. We're good. What you got?
There's just a weird one that I can't set up.
Right.
It's the integral from 0 to negative infinity is 0. And then the fraction is x over the denominator x to the 4th plus 25.
Oh, interesting.
And I know it's an arctan, but I can't
Make it happen.
Yeah, like I don't. Yeah,
It's the U sub. It's not a normal U sub. A normal U sub probably would have been U x to the 4 plus 25, but that doesn't help you. X squared does. If you differentiate that guy, you get 2x. There's your crossover, and there's your isolate. So this fella here, we'll leave him blank for a little bit, well, so we can just figure out this thing. It's going to be x. The dx is going to be 1 over 2x du. And this guy is going to be turned into u squared plus 25. So x to the 4 is x squared squared. So that's why it's a u squared. Now the x's cancel out. And basically what we have here is a half u squared plus 25. I recognize that as the inverse tan. It's a little bit different than just a u. It's the inverse tan of u over 5 and a 1/5. So you're going to get 1/10 the inverse tan of x squared over 5. So I can now return back to this question. It's going to be the limit as t tends to infinity, no, negative infinity, the integral from t to 0 of this fella over 25 dx becomes the limit as t tends to negative infinity of 1/10 the inverse tan of x squared over 5 from x equals t to x equals 0.
I think I got lost from the tan inverse of u over 5, like from that line above it and then to that one.
Right. So what I'm using is a property that says we know we'll just call it x's, right? We know what this guy is, but they're actually a whole family of these guys. So 4 plus x squared would you get you a half inverse tan of x over 2, and 9 plus x squared would get you 1/3 inverse tan of x over 3.
Okay.
Right, now, other point. When you are looking for the inverse tan of infinity, because that's going to happen later on in this process, the inverse tan of infinity is not undefined, nor is it infinite. The inverse tan of infinity is pi over 2.
Yeah.
So that means my gut feeling is this is going to converge to something.
Okay. Thank you.
Is that it? Okay.
You have a good night.
Can I keep this one as always for the others?
Of course.
Thank you then. Bye-bye.